Hi, it's Marco from Donut Lab. You are watching our battery proof series called I Donut Believe. In this series, we demonstrate the capabilities of Donut Battery, which is the world's first solid-state battery used in production vehicles. Ever since CES, people have been questioning one of our claims that you can change the voltage of the cell, because normally that just is not possible. This week, we are going to show you something that will surely raise eyebrows across the industry. It's a real breakthrough, the kind of thing that many of the giants we compete with are still working towards, and it's only possible with a true solid-state design. So we are pulling back some curtain to show you what's actually going on, why this is the holy grail engineers have chased for decades, and how it opens up completely new possibilities. Today is all about bipolar cells, and Ville will tell you more.
Thanks, Marco. So what is a bipolar cell and why is everyone trying to build one? Let me start with the problem it solves. A single cell only gives you a few volts and a vehicle needs hundreds. So the industry chains a lot of separate cells together in series to get there. The trouble is that all of that chaining is packaging. Casings, tabs, wells, bus bars and wiring. And every one of those connections adds weight, adds cost, adds resistance, and adds another place where the pack can fail. A large part of the weight and cost of a normal pack isn't storing any energy at all. A bipolar cell does the same job in a completely different way. Instead of connecting separate cells on the outside, we build the voltage inside the single cell. We stack several electrochemical layers in series inside one cell package. And the plate between the two layers does double duty, working as the electrode for the cathode on one side and for the anode on the other. The current doesn't detour through tabs and bus bars, but instead it runs directly through the stack. And the voltage adds up layer by layer. Let me show you what that actually means, because this is the part people questioned after CES. I have 3 demonstration cells on the table, all built the same way, and the only difference between them is how many layers are stacked inside. So let's measure them. Same chemistry, same basic construction, and the only thing we changed is the number of layers. That's what we mean when we say we can set the voltage of the cell. It isn't a fixed number you're stuck with, it's something we design in. So if you can do all of that, why isn't everyone already building bipolar cells? It comes down to the electrolyte. In a conventional lithium-ion cell, the electrolyte is a liquid, and a liquid will creep between the layers and let the ions flow in all the wrong places. It isn't that a bipolar cell with a liquid electrolyte is flat out impossible to build. It's that sealing every layer reliably is so hard that it stops being worth doing. And this isn't a new idea. Bipolar cells have shown up in research papers since the lead acid era, because everyone in the field can see how much there is to gain. But with lithium-based or higher voltage chemistries built on liquid electrolytes, it has been practically impossible to build one that's commercially viable. The important thing to note is that the cells on this table are not lithium cells. Donut battery uses a different chemistry, and that's the reason we are on track to commercialize this, while others are struggling with challenges of lithium-ion. Because in this cell, the electrolyte is solid, and there's no liquid to migrate between the layers. And that's what makes a bipolar donut battery possible in the first place. And just like every other aspect of this battery, we're going to have this bipolar nature verified by a third party as well in the near future.
Thanks, Ville. As I mentioned before, since CES, many have questioned whether donut battery is really solid-state technology. A bipolar cell working the way this one does should put a nail in that coffin for good. And this matters well beyond the test bench. A pack built from these cells needs fewer cells, fewer wells, fewer bus bars, so more of its weight goes into energy and less into parts that just hold it together. For the companies that build with us, that shows up on the bill of materials. Every housing, weld, and wire you take out is cost you take out, and every connection you remove is one less place for a pack to fail. Fewer cells to manage means simpler battery management system, and a cell that already arrives at the voltage the product needs means that the whole thing is faster to develop. And because the voltage comes from stacking layers, we can set it for each application. A drone builder, a robotics company, a vehicle manufacturer, and a grid storage integrator, all of them can get the voltage and the form factor they need from the same basic cell. The battery stops being the thing you design your whole product around and becomes a component you can simply specify. The whole industry has chased this architecture for decades. The biggest battery companies on Earth all have it on their roadmap slides. And we, on the other hand, have it today right here on our test bench. And it's only the beginning. We are open for business on bipolar cells, and our target is to still deliver the first bipolar cells to customers this year. Thank you all, and see you next time.